Students, in this class we will learn how to show sine 10 to be irrational. Now I would be using De Moivre's theorem to show this proof. Now for any x real number and n an integer, we got cos x positive I times sin x raised to the power n to be equal to cos nx positive I times sin nx. Now you have to know that cos x plus I times sin x has got an abbreviation as cis x, so sometimes they may also use it like this. Now using this De Moivre's formula or De Moivre's theorem, I would be showing sine 10 degrees to be irrational. Now before I could proceed, I want to show you the proof of De Moivre's theorem. Now if I were to take x to be as say 30 degrees and n to be as say 2, then we got cos 30 positive I times sin 30 raised to the power 2 being equal to cos 2 times 30 positive I times sin 2 times 30. Now this is equal to, on the right side is going to be cos 60 positive I times sin 60. On the left side, cos 30. Now we know cos 30 to be as root 3 over 2 positive I times sin 30 is 1 over 2 raised to the power 2. Now this can be rewritten. Now cos 60 is 1 over 2 positive I times sin 60. Sin 60 is going to be root 3 over 2. Now if I were to take the LCM for this, it's going to be 2 and 1 positive I times root 3. So this is on the right side. On the left side, if I were to take the LCM, I would have 2 here and then root of 3 positive 1 raised to the power 2. Of course this is going to be I divided by 2 squared. Now if I were to expand this, okay, if I were to expand this, I would get I squared plus 2 times I times root 3 positive root 3 squared divided by 4, and we know that I squared is negative 1, so this means I would have negative 1 positive I times 2 root 3 positive root 3 squared is going to be 3 divided by 4. Now this is going to be negative 1 added with 3 will give me 2 positive I times 2 times root 3 divided by 4. I can rewrite this as 2 of 1 positive I times root 3 divided by 4. Now 2 divides 4 2 times, so this is going to be 1 positive I times root 3 divided by 2, which is equal to, you see the right side, 1 positive I times root 3 over 2. So clearly the theorem given by De Moivre's holds good. So this is just an example to show you. Now how are we going to use the De Moivre's theorem? Now we would consider cos x positive I times sin x raised to the power 3. Now this is equal to cos 3x positive I times sin 3x. Now expand this. Now I would be using a positive b raised to the power 3, which is a cubed positive 3a squared b positive 3ab squared positive b cubed. Now using this formula, cos x plus I times sin x to the power of 3 can be rewritten as cos cubed x positive 3 times I times, in fact let me write the cos x first, 3 times cos squared x times I times sin x positive 3 times cos x times I times sin x raised to the power 2 positive I times sin x raised to the power 3. So now if I were to simplify this, this is going to be cos cubed x positive I times 3 times cos squared x times sin x positive I squared times 3 times cos x times sin squared x positive I cubed times sin cubed x. So this is rewritten as cos cubed x. I am clubbing all the real quantities together. Now I squared is negative 1. So this is going to be 3 times cos x times sin squared x positive 3 times, of course I should be there, cos squared x times sin x positive I cubed is negative I times sin cubed x. Now this is the imaginary part. Now we actually started with cos x positive I times sin x raised to the power 3 to be equal to cos 3x positive I times sin 3x. So on the left side it is actually cos 3x positive I times sin 3x. So equating the real and imaginary part, and imaginary part, we need only sine, so I would to be equal to 3 times cos squared x sin x negative sin cubed x. Now since cos squared x is equal to 1 negative sin squared x, I can use this here, and so I would now have sin 3x to be equal to 3 times 1 negative sin squared x times sin x negative sin cubed x. Now removing the parenthesis is going to be 3 times sin x negative 3 times sin cubed x negative sin cubed x. Now adding these two would give me 3 times sin x negative 4 times sin cubed x. On the left side it is sin 3x. Okay, now I can rewrite this as 3 times sin x, moving this on the left side would give me sin 3x positive 4 times sin cubed x. Okay, now I need to find out what is sin 10. Okay, so what I'm going to be doing is I'm going to be rewriting this as 3 times sin x is equal to sin 3x positive 4 times sin x raised to the power 3. I'm going to rewrite it like this. Now this can be further written as sin x is equal to 1 over 3 times sin 3x positive 4 times sin x raised to the power 3. Okay, now if I were to take x to be as 10 degrees, I would have sin 10 is equal to 1 over 3 times sin 3 times 10 positive 4 times sin 10 whole power 3. Okay, now this is actually equal to 1 over 3 times sin 30, okay, positive 4 times sin 10 whole power 3 is equal to sin 10. Now sin 30 is 1 over 2, right? Sin, we know that value. So 1 over 2 positive 4 over 3 times sin 10 raised to the power 3, and on the left it's going to be sin 10. Now this is equal to 1 over 6 positive 4 over 3 times sin 10 whole cubed, and you got a sin 10 there. Now let me move this quantity to the left, so that would give me sin 10 negative, in fact, okay, 4 over 3 of sine 10 whole cubed is equal to 1 over 6. Okay, now let me take sine 10 to be equal to x. Now if I take sine 10 is equal to x, then I would have x negative 4 over 3 times x cubed is equal to 1 over 6. So multiplying by 3, we get 3 times x negative 4x cubed is equal to 3 over 6. Okay, so this is going to be 3x negative 4 times x cubed is equal to 1 over 2, which can be rewritten as 6x negative 8x cubed is equal to 1. Multiplying by negative sign, I would get 8x cubed negative 6x equal to negative 1, which can be, of course, rewritten as 8x cubed negative 6x plus 1 is equal to 0. Now we have got this. Okay, now to solve this, we are going to be using what is called as the rational zero theorem. Now what exactly is this rational zero theorem? Now imagine you have a polynomial, say f of x is equal to a n x power n plus a n minus 1 x power n minus 1 positive a n minus 2 x power n minus 2 plus etc. a1x positive a0, where all of these coefficients are integer, where a0, a1, a2, etc. an are all integers. Okay, then according to rational zero theorem, the rational zeros of f of x will be of the form p divided by q, where p is all of the factors of a0, right, and q is all of the factors of an. Polynomial which we have got is 8x cubed negative 6x positive 1 equal to 0, and therefore according to the rational zero theorem, the possible zeros or factors of 8x cubed negative 6x positive 1 equal to 0 will be of the form p divided by q. Okay, where p is all factors of 1, which is plus 1 and minus 1, and q is all factors of 8, which is plus 1 minus 1, plus 2 minus 2, plus 4 minus 4, and plus 8 minus 8. Now we need to obtain p divided by q. Okay, so p divided by q would be plus 1 minus 1 over 1, plus 1 minus 1 over 2, then plus 1 minus 1 over 4, plus 1 minus 1 over 8. So these are the possible, that's a very important word, possible factors or zeros. It can be factors or zeros of 8x cubed negative 6x positive 1. Now clearly, since sine 10 degrees is positive, all of the negative values or negative zeros, possible negative zeros, in fact values is better, possible negative values can be eliminated Okay, so because of this fact, so what have we got? And also sine 10 cannot be equal to 1, okay, and sine 10 degrees cannot be equal to 1 over 2. So we can eliminate plus 1 and plus 1 over 2. So what remains now is what? What remains are plus 1 over 4 and plus 1 over 8. So this implies the possibility of factors for 8x cubed negative 6x plus 1 equal to 0. If it is rational, then it should be 1 over 4, 1 over 8. So substituting 1 over 4, we get 8 of 1 over 4 raised to the power 3, negative 6 times 1 over 4, positive 1. Now this is clearly not equal to 0. And also 8 times 1 over 8 the whole cube, negative 6 times 1 over 8, positive 1 is not equal to 0. So this implies neither 1 over 4 nor 1 over 8 can be a factor or a 0 for 8x cubed negative 6x positive 1 equal to 0. So this implies the only possibility being irrational factor or 0. This is the only possibility, irrational 0. Okay, so this implies sine 10 degree should be equal to an irrational number. Okay, so that concludes the solution for this question.